Listen. So I'll explain the last problem once again. Okay, the infinity ladder. So yesterday we were seeing this problem, no? We have taken this as a C. So we were using this concept like, for example, root 7 plus root 7 plus root 7, and it's going on. Okay. So we have considered this as equals to x. If this is equals to x, so the other terms which are continuing, no, up to infinity, I can consider that as a x. So which is nothing but root 7 plus x will be equals to x. So if I take the square on both sides, it will become 7 plus x will be equals to x square. So x square minus x minus 7 will be equals to 0. So I got a quadratic equation. So from minus b plus or minus root over b square minus 4ac by 2a, I can get the value of x. So similarly, if I talk about this one, the potential difference between these 2 points as x, so I can consider this whole term as x. Okay, I can increase this also, no, this side also, again this also will be x only, no. So I can take this as x and this as x. So now what I can do is, I can redraw the diagram here. So this is my x and this is my c. Again see, the potential difference between them is again x. So what is the formula for the parallel? C1 plus C2. If this is C1 and this is C2, what I can do? C plus x, and this one will be C. Is this series or this parallel? Series. Okay. So series in the sense 1 by x will be equals to 1 by C1 plus 1 by C2, which is nothing but C plus x. So cross multiply these two things, C plus x plus C divided by C times of C plus x equals to 1 by x. So what happens this one? 2c plus x divided by c square plus cx equals to 1 by x. So cross multiply the things, what I will get? C square plus cx will be equals to 2cx plus x square. So keep the x square in one side, take the remaining term to the other side. So which is nothing but x square plus 2cx minus cx minus c square equals to 0. So 2cx and minus 1cx will become plus cx minus c square will be equals to 0. Is this looking like a square plus b? No. Ax square plus bx minus c, plus c equals to 0. Correct, no? So can I say like minus b plus or minus root over b square minus 4ac by 2a? So what is a here? A equals to 1, b equals to c, and c will be equals to minus c square. Okay. Any doubt up to this? Any doubt? So minus c plus or minus root over c square minus 4 times 1 times minus c square by 2 times 1. So which is equals to minus c plus or minus root over c square, minus and minus will become plus, and this is 4c square by 2. So it is minus c plus or minus root over 5c square divided by 2, which is equals to minus c plus or minus c, I can take out now, c square into root 5 divided by 2. So what are the two roots here? Minus c, or let me take out here minus, c also outside. So minus 1 plus or minus root 5 by 2. Okay, now I can say the two roots here. So one root is c minus 1 minus root 5 by 2, and one more is c root 5 minus 1 by 2, correct? No, 1 plus root 5, I have rearranged it as root 5 minus 1. Okay, so obviously the value won't be negative for the capacitor, so obviously this is the answer for the question, c root 5 minus 1 by 2. So any doubt in this? If you have not taken, you can take down. Still So what is the concept we have studied in Wheatstone Bridge in IP? What is the concept? What is the ratios? R1 by R2 equals to? Okay. So here like if I consider C1 by C2 is equals to C3 by C4. Like you can take these two and these two. Okay. If these two ratios are equal, I can neglect these things. Okay. I can neglect the thing. So this is a Wheatstone Bridge concept, and we will do a problem based on this. You can take this diagram. I will give a problem now. So don't depend upon C1 by C2, C3 by C4. Like see the ratios of these two things and these two things. Okay, top and bottom. Completed. Take the topic, plate problems. So listen carefully. So here the problem is given like this. I need to resolve into a capacitor circuit. Okay. So if I see here, this A has been connected to 2 plates and B is connected with 1 plate. Like totally 3 plates are there, no? 1, 2, 3. Yes, no? If I talk about the first one, this is surface 1, this is surface 2, surface 3 and surface 4. Correct, no? First one, second one, third one and fourth one. The outer part I can't consider. Okay. If I talk about, for example, this is my capacitor, this is my surfaces, no? 2 surfaces. Will I consider this as my surface? No, right? So 1, 2, 3, 4. 4 surfaces are there. So how to resolve is, take any one, like I will take A here. So A has been connected with 1 and 4. So this is 1 and this is 4. Correct, no? So what is opposite of 1? 2. Opposite of 4 is 3. So can I connect these two things with B? Now if I see here, B is connected with 2 and 3 and A is connected with 1 and 4. I got a capacitor, no? What capacitor is this? Parallel capacitor. Getting the points? Take down. I will give more problems on this. Will do. So always ignore the outer parts. Okay, always ignore the outer parts. Either you start from here or either you start from here. If you start from here 1, 2, 3, 4. Or if you start from here 1, 2, 3, 4. Okay. You can write down the points. First thing. Completed. So first point is mark the number of plates. Mark the number of plates. How many plates are there? First thing, 3 plates are there. First thing is I need to count how many plates are there. Second point is mark the number of surfaces. Third point is ignore the outer surface. Ignore the outer surface. Done? Okay. Is this completed? So this is A and this is B. How many plates are there? 4 plates. First point. Okay. How many surfaces are there? 1, 2, 3, 4, 5, 6. Right now? So can I mark like this? I need to ignore the outer surfaces. So if I ignore the outer surface, this is my 1, 2, 3, 4, 5, 6. Okay. So first thing I will start from A. Any doubt up to this? So first I will take A. How many plates are there for A? 1. Okay, so 1 is opposite to 2. Then 4 is there. 4 is opposite to 3. Then 5 opposite to 6. Any doubt here? So okay, first let me complete the first problem. Take the value as 5 and this as 15. What is the answer? This much time. 20. Okay, I have solved the second problem and try to solve now by your own. Solve it now. Second one. No values. Just draw the diagram. We'll see. Not correct for the second one. Try to analyze where we have made mistake. 5 4. A is connected with how many surfaces? Huh? 2. Then why we have taken only 2 there? Huh? Three will be there first, then 4, 5. Then find it for B. 2 is there, opposite of 3. So 6 is there. So connected with this is the answer. Getting? Understood now? I'll give one more problem. Try to do it. One, 2, 3, 4. A. And this is B. Try to resolve for this one. We'll see. Try to resolve. How many plates are there? 6 plates. 4 plates, 6 surfaces. Then how many surfaces for A? Only 2 surfaces. Draw the first diagram for A and then give the marking for B. Take out these packs. Listen. How many surfaces? 1, 2, 3, 4, 5, 6. So A I will take first. So A is having 2 and 3. Now this is opposite of 1 and this is opposite of 4, no? That's it. Now what is the thing remaining? 2 is connected with 1 is connected with 6, no? 1 is connected with 6 and 6 is opposite to 5. Any doubt here? Still any doubts? 5, 4 connected with B, 2 and 3 connected with A, and I have got 1 and 6 also in between. Any doubt? Any doubt? So I can draw like this also, no? B. Once again I will explain, listen. So 6 surfaces are there. I have taken first one as A, so A is connected with 2 and 3. So 2 is there, 3 is there. So 2 is opposite of 1. 1 I have taken, and 3 is opposite of 4. 4 also I have taken. That's it. Now if I see 1 is connected with 6. Yes, no? 1 is connected with 6. So it has been connected with 6. Connection has been completed. And 6 is opposite of 5 I have taken. Now if I see 4 and 5 are connected with 4 and 5 connected with B. Circuit has been completed. Take down. Completed. So any doubts in the plates problem now? Any doubts? Write on next chapter, current electricity. So what is the direction of field? Direction of field, positive to negative. Fine. So if I talk about the wire, and if I talk about the field direction and electron direction, both are opposite in nature. Okay. If I talk about this is my positive and this is my negative, field will be from positive to negative. This is the thing we have learned in the direction of the field, no? Electric field lines. It is originating from positive, terminating at negative. Correct only, no? But electron flow from negative to positive. So this is flow of electron, I will say. So flow of electrons. So this is the first point in the current electricity. Take down. write on the point. Electrons will go from low potential to high potential. Electron will go from low potential to high potential. Okay, write down the subheading current. First point, current is the rate of flow of charge. Current is the rate of flow of charge. Second point, current as direction, but it is a scalar quantity. Because it doesn't comes under vector addition. So current usually will denoted by the letter I, right? No, so I is nothing but the rate of flow of charge, which is I is equals to dq by dt. Q is nothing but charge, no, so dq by dt. SI unit is ampere. So if they are asking 1 ampere means 1 coulomb per 1 second. 1 ampere is nothing but 1 coulomb per 1 second. Charge is nothing but coulombs, no? SI unit of charge, and SI unit of time is seconds. So 1 ampere is nothing but 1 coulomb per 1 second. Completed. The next topic is current density, which is denoted by the letter J. Current density. First point, it is the current flowing per unit area. Second point, it is a vector quantity. And its direction is along the direction of current. So the formula will be J is equals to I by area. So I by A, current by area. Or I can say I is equals to J dot A. Write down the question. Find the number of charge. Find the number of charge flowing through. Find the number of charge flowing through a cross section. If 1.6 ampere, if 1.6 ampere current flows, if 1.6 ampere current flows for 10 seconds, full stop. Also find the current density. If the cross section is 10 meter square. Okay. So what are the given terms in the question? First thing they have given, how much? 1.6. Second thing, time they have given, t is equals to 10 seconds. Then cross section area they have given, A is equals to 10 meter square. So everything is in SI unit, no need to worry about the units now. So what is the question they were asking? To find the number of charge, right? Now to find the number of charge. Then second question is number of charge and current density. So when I talk about the solution, the first one, what is the formula for the current? I is equals to Q by T, right? No, Q by T. So current they have given and they have given time. It is charge. What is the formula for Q? Q formula, I into T. What is the formula we have learned in electrostatic? Starting first point. Q is equals to N times E. Q is equals to NE. Once you take down, it is quantized. Yes, no? I can say that NE by T. Now I can find the number of electrons or number of charges. No, N is nothing but number, no, the integer. So can I say like I will be equals to NE by T, where N will be equals to IT by E. So from this I can find the number, right? No, I can find the number. Second question, what they are asking? Current density. So J is equals to I by A. So I can find easily, like I they have given directly, A also they have given. So how much? 1.6 and this is 10. So which is nothing but 0.16 density. Yes, no? 0.16. What is the unit? Ampere per meter square. So this is my density. So what is the answer for this one? Get the answer now. First, do the calculation. Tell me, sir. Which one, sir? Why, for what we are using integration here, sir? No. No. Why? They are asking about the number of charges only, no? N I need to find. Number of Q they are asking, no? Yes. So 1.6 and 1.6 will get cancelled off, and this will go to the power numerator. So 10 power minus 19 will become 10 power 19, and yes, fine. That's correct. So any doubts? So 1.6 times 10 divided by 1.6 times 10 power minus 19. 1.6 and 1.6 will get cancelled off. So the 10 power minus 19 will go to the numerator. It will become 10 power 1 into 10 power 19 will be 10 power 20. That's the answer. So N is equals to 10 power 20. So for 1.6 ampere, these many charges are flowing. Completed. Can we go for the next topic? Everyone, write down the topic. Speed of the electron. Speed of the electron. First point, speed of the electron. The first point is the typical speed of the electron. The typical speed of the electron. The typical speed of the electron in a conductor. The typical speed of the electron in a conductor is up to 10 power 5 meter per second. Done. Second point is the average velocity is 0. The average velocity is 0. But the average speed is not equals to 0. But the average speed is not equals to 0. But the average speed is not equals to 0. Done. Second subheading, speed of electricity. Speed of electricity. Electrons we have completed. Now the speed of electricity, which is nothing but you can take in bracket a speed of a field, electric field. Speed of electric field. First point, it is equal to it is equal to speed of the light. It is equal to speed of the light. Second point, electric field inside a conductor is sets up sets up almost instantaneously, you can write sets up almost instantaneously. Next subheading, drift velocity. Drift velocity. Drift velocity. Drift velocity. First point, it is the average velocity of an electron. It is the average velocity of an electron. It is the average velocity of an electron with which it drift upon application of potential difference. Application of potential difference. Second point, typically it is 10 power minus 6 to 10 power minus 3 meter per second. Typically it is 10 power minus 6 to 10 power minus 3 meter per second. So the formula is I is equals to NVEA. So if you are using this laptops and all, no, like the graphic cards will be there, NVIDIA graphic card, so you can remember that formula, NVIDIA. Okay, like you can relate the terms and you can remember the formula. Now if I talk about the drift velocity, V will be equals to I divided by NEA. This is my drift velocity. Okay, now write down the terms. I is nothing but current. What is N? The number of electrons. Number of electron. V is nothing but drift velocity. E is nothing but 1.6 into 10 power minus 19 electron, right now, and A is nothing but the area. So can I write this drift velocity in terms of current density? I by A is equals to NVE, which is nothing but I by A, current density, no? So J will be equals to NVE and V will be nothing but J by NE. This is the formula in terms of current density. Okay, the question is, if the area increases, what about the density? Area increases, what about the density, current density? Increases, decreases, no? Inversely proportional to each other. J is equals to I by A, which is nothing but if A increases, J will be decreases. Okay, write down the next one. Question. A current of 3 ampere a current of 3 ampere is flowing, a current of 3 ampere is flowing in a copper conductor, in a copper conductor with a cross section of 1 millimeter square, with a copper conductor with a cross section of 1 millimeter square, full stop. Find the drift velocity, find the drift velocity of electron, find the drift velocity of electron, where n is equals to, where n is equals to 8.5 into 10 power 28 per meter cube. What is the meaning of per meter cube? M power minus 3. N is equals to 8.5 into 10 power 28 per meter cube. 10 power 28 m power minus 3. Okay. Now find the drift velocity first. Convert everything to same SI unit. 1 millimeter area. How much they have given area? Convert that to meter square. One millimeter square is equals to how much meter? 10 power minus 3. 1 millimeter 10 power minus 3. Meter square, millimeter square minus 6. 0.022 into 10 power minus 2. Fine. 2.2 into 10 power minus 4. Correct. Minus 4. Then got the answer. Still doing. Three divided by 8.5 into 10 power 28 into 1.6 into 10 power minus 19 into 10 power minus 6. Take out the 10 terms one side and keep the values. Don't ever keep the values in the decimal points. Don't keep the values in the decimal points. It will be uneasy to calculate it. If you are comfortable and calculating in decimal point, you can keep it. Otherwise, remove the decimal points. 0.2 2 0.22 into 10 power minus 3 minus 3, either 0.022 or 2.22, whatever it is, but what is the power you need to see. I'll give the answer here. It is 2.2 into 10 power minus 4. This is the answer. So you can take the answer somewhere and you can calculate it. So if the option is like 0.022, if they are asking like that, so take the decimal accordingly and power accordingly. Okay, you can take the answer. We'll go for the next one. You can calculate it. I'll give time at last, 10-15 minutes I'll give time. Write down the next one, Ohm's law. So Ohm's law says that V is directly proportional to I. So V is equals to IR right now to remove the proportionality. And what is V? Potential. I is nothing but current and R is nothing but resistance. So the graph between V and I will be, it is a straight line. So from this we can say that if V increases, I also increases, R also increases. So can I say like V is directly proportional to I, V is directly proportional to R, and what about I and R? If I increases, R decreases. If I decreases, R will be increases. Like both are inversely proportional to each other, right? Write on the subheading if you have completed. Saving books. topic resistance. The topic is resistance. Resistance. First point, the electrical resistance of an object is a measure of its opposition to the flow of electric current. And the second point is the symbol is, this is my resistance symbol. Third point is the SI unit of resistance is ohms. SI unit is ohms. So SI unit of potential is V, current is A, and R is ohms. Subheading under the resistance depends on geometry and material. So resistance is directly proportional to the length and resistance is inversely proportional to the area of cross section. If I club together, R will be directly proportional to L and inversely proportional to A. To remove the proportionality, R is equals to rho L by A. So where R is nothing but resistance, L is nothing but length, A is nothing but area of the cross section, and rho is nothing but resistivity. Okay. The next point is conductivity. So which is denoted by the letter sigma. So conductivity is opposite of resistivity. So sigma will be equals to 1 by rho. That's it. This is my conductivity. Write down next point. Resistance is also depends on the next one. Resistance is also depends upon the temperature. Resistance is also depends on the temperature. First point, under this first point, resistance of a conductor is increases with temperature. Okay, so what was the formula we have learned in thermal properties of matter for the linear expansion? Delta L is equals to L times of 1 plus alpha delta T. Remember the formula? Delta L is equals to L times of 1 plus alpha delta T. Have you remembered the formula? Yes or no? So I can relate the same formula here. This is my change in resistance and equals to initial resistance 1 plus alpha delta T. This is the formula. Take down. So R is the change in resistance, R naught is the initial resistance times 1 plus alpha delta T. So I will give a question now, we will see who is going to do this question. It is a little tricky question. Before that I will complete a topic. Write down the topic. Completed this one. Write the topic. Electric field inside a conductor. Electric field inside a conductor. First point. So what we have learned about the field inside a conductor, properties of conductor in terms of charge, field, potential, we have learned, no? What is the field inside a conductor? 0. Right on the first point. For a static charge conductor, field inside is 0. For a static charge conductor, field inside is 0. Second point, but when charges are drifting, the field is not equals to 0. When charges are drifting, field is not equals to 0. And the formula is E is equals to J times rho. What is J? Current density, I by A. What is rho? Resistivity. Write on next topic, relaxation time and mobility. First point, relaxation time, the first point, relaxation time is the time gap between two successive collision of electron. In a conductor. Second point, mobility of an electron in a conductor, mobility of an electron in a conductor is defined as the magnitude of the drift velocity, the magnitude of the drift velocity per unit electric field, per unit electric field. Per unit electric field. Write down the formula. Drift velocity is equals to small e into capital E, small e into capital E by m into current density. Wait, it's not current density, it's a relaxation time, tau. Drift velocity is equals to electron into electric field by mass of the electron into tau, it is relaxation time. You can write E is nothing but 1.6 into 10 power minus 19, capital E is nothing but electric field, m is nothing but mass of the electron, and tau is the relaxation time. E is equals to 1.6 into 10 power minus 19, capital E is equals to electric field, m is equals to mass of the electron, and tau is equals to relaxation time. Now, what is the mobility definition says? Read the definition. What is the ratio they are talking? Magnitude of drift velocity per. So, V d by E is equals to, I have taken this E this side, E by m into tau. So, is this my mobility? And mobility is denoted by the letter mu. So, mu is equals to E by m times tau. This is my mobility. That's it. Drift velocity per unit electric field. The last point I will say, and I will give a question. So, relaxation time is inversely proportional to the temperature. You can take this point. Relaxation time is inversely proportional to the temperature. Okay. The question now. A wire of a resistance R, with initial radius r, small r, with initial radius small r, and then it has been stretched, so the radius becomes r by 2. So, the radius becomes r by 2. Then what is the new resistance? This is the question. Then what is the new resistance?